A very good morning to my friends and doctor. Today we are here to present about our group assignments for part A. By using the data given in Appendix 1, we select a sample of data in 50. First, we divide the data into 6 groups. In the group, the minimum number is 18 and the maximum number is 124. The class Y is 18. Next, for question 1, the sampling technique using in this data in simple random sampling and the type of data is quantitative data. Beside the level of measurement is the interval scale. For the question 2 is a Power table. The first is frequency distribution. The frequency distribution built up in the 6 class and the total frequency is 50. The second is the relative frequency. The relative frequency can be found by using the total frequency divided by frequency each class, and the total relative frequency will be in 1. The third is cumulative frequency. The cumulative frequency is calculated by adding each frequency for a frequency distribution table to the sum of each process. The last value will always be equal to the total for all observations, since all frequency will already have been added to the previous total.
Hi, my name is Yong Zhenxian, normal matrix HFT20203 So I'm going to continue with part A, question 3 and 4. First, we're going to develop two suitable graphical method, and we have developed histogram and frequency polygon. For histogram, the x-axis we're going to use the upper boundaries, and the y-axis we're going to use the frequency to develop the histogram graph. And for frequency polygon, the x-axis we're going to use the midpoint, and for the y-axis we're going to use the frequency to develop the frequency polygon graph. Next, I'm going to continue with measures of central tendency, which is the mean, median, and the mode. So for the mean, before we calculate the mean, we have to calculate the midpoint and the fx for each class. And for the fx, how to calculate it, we have to use the frequency multiplied by the midpoint to get fx. So this is the formula of mean, and the mean is the total of fx, which is 3449, divided by the n, which is 50, equals to 68.98. Next is median. The way to get the median is with the sum of the frequencies divided by 2, then look at the cumulative frequency where the number is n. Take the class and calculate together with the lower class boundaries and class size. So this is the equation of median, and after calculate it, the median of labor force is 103. Next is the mode. The way to get the mode is the class with the highest frequency count with class size and so on. So this is the equation of mode, and before we calculate the mode, we have to get the lower boundaries, which is 53.5, the class wide, which is 18, and for the square 1 is 9 and square 2 is 3. And after calculate it, the value of mode is 67. Next is the measure of position. There are 3 measures of position, which is quartiles, deciles, and percentiles. In this video, we will discuss more on quartiles. And first, we have to calculate the location of Q1 and Q3. And for Q1, the location is 12.5 by referring the location of Q1 on cumulative frequency column. Therefore, the class interval is 36 to 53, and for Q3 is 37.5 by referring the location of Q3 on cumulative frequency column. Therefore, the class interval is 72 to 89. And after we calculate the location of Q1 and Q3, by using this equation, we will calculate the Q1 and Q3. And therefore, the Q1 is 46.75 and the Q3 is 90.4. And the interquartile range is 43.65. Measure of variation. There are 3 measures of variation, which is range, variance, and standard deviation. So for the range is the maximum value minus the minimum value. Therefore, the range is 106. And by using the equation of variance and standard deviation, the sample of variance is 53,595.70 and the sample of standard deviation is 208.80. And last is the shape of data distribution. By looking at the value of mean, median, and mode, therefore it's skewed to the left because mean smaller than median, but median bigger than the mode.
Part B. Find one set of data that have independence variable and one dependence variable. For this question, independent variable is study times minutes and dependence variable is result mathematic performance percent. This is for example for this question. For part B number 2, explanations for sample size, type of data, and level of measurement. Sample size, the number of observations or data points in the data set is referred to as the sample size. There is 30 pairs of data for study times minutes. Result mathematics performance percent in the example given. Type of data, quantitative data types are the most common sort of data. Result mathematic performance is determined by performance and working time studies minutes are a countable measure of time. Level of measurement, the measurement level for both variables is a ratio. Mathematical operations such as multiplication and division are possible at the level.
Assalamualaikum and hi everyone. My name is Afifah Ayuni binti Abdullah. My metric number is H2020699. Today I would like to tell you about my part, which is the statement. So the statement is, if the data consists of n greater than 100, you may select at random n not greater than 100 but must be at least 30. For example, n equal 50. So this is the data that my group has collected. That is n equal 30 sample study times minutes, which is minutes. So for example, study time which is minute, 5 minutes equals 5 study time which is 5 minutes, and the result mathematic performance is 6.5% and further. Thank you.
I will continue on the percent correlation coefficient, which is this part. You must find what the summation of x and y. Okay, first of all, you must have all the data that have been given, and as you guys can see in the slide, I put the half of the data of the table because there's a lot of data. But for example, only you guys can see at the table, which is how to get the summation of x and y. First of all, you must have the independent and dependent variables. At the column 1, which is study time, is the independent variables. You must calculate all the data to get the summation of x. Same goes to the summation of y. Must calculate all the data from the result of mathematics and to get the summation of y. While for the summation of x and y, how to calculate and how to get the data or how to get the value. Okay, first of all, when we have the data of independent and dependent variables, for example, you look at the tables. For example, I take the number of 15. Okay, 15 times with 10, and then you can get the amount of summation of xy, which is 15 plus time with 10 and get the 115. Okay, so same goes how to get the amount, the last amount. Just calculate all the data from the table. Next, how to get the summation of y or summation of x power of 2. Okay, this is the easiest way, which is you get the data from the independent and dependent variables. For example, from the study time table, I got 42. Okay, for the amount of 42, just put in the power of 2 and then you can get the amount of summation power of 2 is 1764. So same goes to the summation of y for power of 2. Just take the value from the independent or from the dependent variable, which is the result, and then put the power of 2 to get the summation of y power of 2. Okay, this is the example of the formula that you guys can use for the person moment correlation coefficient part. Okay, for this calculation or for the formula, you must remember if it was not provided in the exam. Okay, but I just proceed to the how I calculate the amount. Okay, you must know how the value, or what is the value of the summation of xy, what is the value of the summation of x power of 2, y power of 2, and so on. Okay, so you must calculate all the amount, and then you can get the all the data and put the put below as the formula has been given. Okay, you guys can get the formula and then put all the amount that we just calculate just now, and then put in the bracket, and then just count as usual. Okay, for example, which is R is a product moment correlation equal to 13, which is n or a sample, and in parenthesis 52,455 in parenthesis also, and then subtract with the parenthesis 660 in parenthesis, and also parenthesis again 835 and then in the bracket, then divide by the square root of, first you must put the bracket and then put the amount of n, which is sample 13, and then parenthesis 23,778, and parenthesis again 616, and parenthesis, and don't forget to get the, or to put also the power of 2, and then in another bracket put the amount of 13 and parenthesis 46,934, and the parenthesis again subtract with the parenthesis 835 and also power of 2, and close the equation with the bracket. Okay, the answer for the first part, which is 1.025 divide by the square root of 1.97. So you can get the answer same with the 0.73. That's all.
So we move to the table. We can see here a breakdown of the key point in the table. Multiply R is a 0.9608. This represents the strength of the linear relationship between the independent and dependent variable. A value closer to 1 indicates a stronger positive relationship, whereas a value closer to 0 indicates a weaker or no relationship. In this case, the value is quite high, suggesting a strong positive relationship. Okay, for the R square, we can see is 0.9231. This represents the proportion of variant in dependent variable that can be explained by independent variable. Similar to multiply R, a value closer to 1 indicates a better fit of the regression model to the data. In this case, the R square value is also quite high, indicating that the model explains a good portion of the variant in Y. So we move to the ANOVA table. This part of the output show the result of an analysis of variance test. It helps determine whether the independent variable has statistically significant effect on the dependent variable. The F statistic and its p-value are the key here. The p-value of 1.4473E16 is much less than 0.05. The typical threshold for the statistical significance. This suggests the independent variable has hardly significant effect on the dependent variable. Okay, so the regression equation is also provided. Y equal negative 6.386 plus 1.5468 study time per minute. This equation allows you to predict the value of y for any given value of study time. For example, if a student study for the 100 minutes, you can predict the y value to be around 168.54. Overall, the image suggests that there is a very strong positive linear between study time and dependent variable. Presumably, some measure of academic performance. This means that as students spend more time studying, their performance is predicted to increase. Okay, so we move to the interpretation. Regression coefficient. We can see the b null is the b null y-intercept equal negative 6.386 and b1 slope equal 1.546. Okay, thank you for everyone.